I'm Bubba Knight with Load Test, work in the BD world of trying to help everyone understand how to use the technology and make their foundations more efficient. Speaking of efficient, job of introducing Jack Hayes here. Jack began his tour in the geotechnical world, Queen's University in Kingston, got his BS in civil, continued with soil mechanics postgraduate work for his DIC from the Imperial College in London in 1962. For the next 40 years, he endeavored to do projects in Africa, Canada, the United States, and eventually with those, the Osterberg cell and Load Test worldwide. Worked on earthen dams, harbor facilities, multi-story buildings, railway, highway projects, and other infrastructure projects to the sum total of excess of 4,000. As a founder and president of Load Test Incorporated, prior to his retirement, he was heavily involved in developing the Osterberg cell and its usage worldwide. There were more than 1,000 O-cell bidirectional load tests done during his tenure. Jack's knowledge and application and thought processes on use of the O-cell and addressing and drill foundations took, as I frequently say, the old foundation of a 42 or 48-inch drill shaft loaded to a few hundred tons to mega foundations of 9 to 10 feet loaded to thousands of tons has pushed and grown the industry tremendously. In his post-engineering endeavors, Jack works on his golf swing. And he tours with his wife, Sally, and does lots of things enjoying retirement. A couple of things on a personal note, I guess, for myself. I had the privilege of going a round of golf. I'm not going to call what I do playing golf. Jack made the observation, he says, for as bad a shots you hit, occasionally you hit a tremendously good shot. Now, I'm not sure exactly what he was telling me other than I'm not too good at cow pasture pool. But anyway, the other thing on that in terms of the professional approach or in doing the work is I remember the phone would ring when I was with FDOT and we were pushing the envelope on doing some things with foundations. Jack would answer the phone, or I'd answer the phone, it'd be Jack on the other end. And he would say, I think it might be good if we could do this. And I learned there was wisdom in that. So to that end, I give you Mr. Jack Hayes to give us some wisdom. And prior to that, Jack, if you will come up, Teresa wanted us to go ahead and give you the presentation award.
Thank you. Teresa told me we're doing this now because after my talk, they might not want to give it to me.
Thank you, sir.
Thanks, Bubba. Well, ladies and gentlemen, I wish a few more of you had come up front, but I'll just have to focus on the ones that are here. It really was a surprise and an honor for me to be selected to deliver this memorial lecture for George. The memorial lecture was actually something that I had a little bit to do with in the beginning because our first major contribution to the DFI Educational Fund was a sum that was big enough to interest them in having a memorial lecture in George's honor. I know this is going to bother Teresa when I tell it to you, but I created this talk as a written thing. I think they're going to publish it in their magazine. And so I I've been trying to convert the written paper into something that I can speak about in what's probably going to be about 15 minutes left by the time we're finished. It occurred to me that the script that I had devised from the written thing it's just really not going to be possible for me to finish this off in the time allowed here. And this, I don't know how many of you are aware of your right brain, left brain activity, but you know, I found that my right brain actually pretty valuable to me because quite often after a night of dreaming, when I wake up in the morning first thing, the right brain comes up with some pretty decent ideas, and it's a good time to jot them down. This morning, I woke up and my right brain was talking to my left brain, and it was saying, "What the hell were you thinking?" And you know, the left brain is the logic side, and we can get carried away with our logic. We're engineers after all. So right up front, I want to tell you that the title of my talk here, the Quantum Mechanics and Deep Foundation Design, is a little bit of a lost leader. I was hoping that the title would make people think that, well, okay, maybe there's something serious here. It turns out that there are some quantum mechanics discoveries, let's put it that way, that are quite appropriate to what we do. But before I get into that, there we go. I want to show you this slide, which has a lot of information on it. And it's one that brings back a number of memories for me. And a lot of the things that I know and remember about Jorj are things that most people wouldn't have. I only knew him for the last 18 years of his life. I knew of his reputation before that, but actually working with him, traveling with him, and going to conferences was quite an amazing thing. I mean, it didn't matter where we were in the world, Hong Kong, Singapore, Dubai, Istanbul. Jorj was treated like a rock star, because everywhere we went, there were all kinds of his former students and former colleagues, and they all wanted to get together and get pictures taken with him, and then invariably somebody would set up a party for the evening, and so it was a phenomenon. But it told me that he must have been a hell of a mentor and a hell of a teacher, because the evidence sure pointed that way. Some of the adventures that I had with Jorj were pretty interesting. I remember in Istanbul at the international conference, we were at one of the evening soirees that we all went to in buses, and after the thing was over, we were walking over a fair distance to get to the buses, and Jorj got off talking to somebody over here, and my wife and I were talking to somebody over here, and by the time we got to the bus, there was only one left, which is the one to our hotel, but Jorj wasn't there. Now this really was a great concern to me, because he'd got to the age where his family entrusted me to be his chaperone or caretaker when we're on these things. And I looked everywhere and couldn't find him, and I thought, oh my God, I've lost Jorj. So we get to our hotel, and Jorj isn't there, and that was another moment of trepidation. Well, a little while later, he shows up, arrives in a police car. And I'm thinking, what the hell happened here? And so he tells a story. Well, he said he didn't realize he got on the bus, wrong bus, until he got to the wrong hotel. And then he wasn't sure what he should do, but he didn't think the hotel that we were going to was that far away, so he decided to walk. Now, this is midnight in Istanbul. He's walking through the streets trying to get to the hotel, and fortunately, the police came along and picked him up before somebody else might have. Jorj was had a great sense of humor. He always liked, in early days, he always liked to start his talks with a joke. And a lot of people would come to his talks because they wanted to make sure that they heard his joke. Well, the last one, he'd been getting on a little bit, and the last one that I remember, he started off his talk by saying, well, he said, I hate to disappoint you. He said, but I don't really have a joke. He was probably about my age at the time. He said, no, I don't really have a good joke for you. He said, I can't even think about a good Viagra story, I can tell you. Of course, that got a good reaction. But he always had a great sense of humor and wit. And a few years ago, at the ASCE lecture in Denver, where he was given the Hero Award for lifetime achievement, we were sitting at our table prior to him going up to receive the award, and a young female reporter from the Denver Post was there, asking him a lot of questions, taking a lot of notes. And after a little while, she said, my gosh, Dr. Osterberg, you've really done a lot in your life. She said, how old are you? He said, I'm 92. She said, 92, my goodness. She said, would you like to live to be 100? He said, if I was 99, I would. Well, unfortunately, he didn't live to 99. He died the next year, 93. But I have to say that those 18 years that I spent working and traveling with Jorj were some of the best times of my career. I told you about what my right brain said to my left earlier, and the what were you thinking part was how are you going to take some of these concepts and fit it all into about 15 minutes. So I realized that wasn't going to happen. What my right brain was saying is that, look, you came here to talk about certainty, so you better start talking about certainty early on. So the only thing I'm going to say about this particular slide is that my introduction to physics, Physics 101 at Queens, was from the professor who said that, talking to a lot of us civil engineers, the only thing he said you civil engineers are going to need to know is that F equals ma and you can't push a rope. And indeed, he was correct. You know, in the Newtonian world we live in, that's pretty much all we do need to know in terms of physics, except that we definitely learn very quickly that gravity and the force of gravity is the thing that we have to deal with. And we have to deal with that acceleration part of that equation, because the last thing we want is for any structure that we support or build accelerates. But the contribution of physicists to our understanding of what's going on in the world ends up coming down, for me anyway, to this idea of quantum gravity. They got the special theory, or the general theory of relativity, and the quantum mechanics people have got all the answers. They're pretty certain that they have the mathematics and the equations to predict just about anything that happens in the universe. The only thing that they still aren't sure about is gravity, and the quantum guys are thinking that gravity, which is all around us if you think about it, is actually particulate. and the thing that makes the particles work, the gravity particles work, is actually information that's being transmitted from one gravity particle to another. Now, I have a hard time picturing that, and this is still only hypothetical and speculation on their part, but this whole idea that information is that important to the way gravity works, it basically said to me, well, information is actually what runs the whole universe. And the more I thought about that, the more I thought about it certainly runs our earthly part of it. So how do we move from this idea of the importance of information to our field? And the thing that's important is that we live in an uncertain world, but we need to be working towards certainty in things that we do. And in order to do that, we need good information. Poor information or no information produces uncertainty. Unfortunately, at some time in the past, we engineers decided that because we didn't know everything, we didn't have enough information, that we would cover up the uncertainties we had by with some sort of factor. And from a promotional point of view, calling it a factor of safety was probably brilliant, because as we did these things and we found that we were more and more uncertain, all we had to do was keep increasing the factor of safety. And of course that made everyone that gets our stuff think, oh, they're really making sure this is going to be a safe project. The fact is, the higher the factor of safety really means that we've got a higher factor of uncertainty. And uncertainty never produces a safe foundation. I'm going to move on here a little bit and ask a question, and that is, why have we decided to acquiesce to uncertainty when our goal and our effort should be towards certainty? The formula to me that really makes sense is that C equals EI, where C is certainty, E is for excellent, high quality expertise, and I is information. Now, most of us as geotechnical engineers would love to have the wherewithal to do the things that we think we need to do for certainty, but what we usually end up with, WWL, where with less, or where with little. And my conclusion is that we have an economics problem. we geotechnical engineers haven't really been very good at illustrating to people the value of what we do and the value of information that we need in order to approach certainty in what we do. So what I wanted to do here is a little example of what I decided, actually this morning, my right brain came up with this. I'm going to call it the 2H process. And I want everybody here to think about joining the 2H club. You know, we've already got a 4H club, but 2H would work for us. And so here's how I'm going to demonstrate this. We start by summarizing the geo properties of the site. And step 2, we calculate a hypothetical design assuming allowable code values for side shear and end bearing and code resistance factors. And then we calculate another hypothetical design assuming much more what we know to be achievable values of side shear and end bearing, and using a resistance factor of 0.9. Now, if we have full certainty, we could, in fact, use a factor of 1. And then the next step is the important one, to calculate the cost of those two hypothetical designs. And so here's a design that I put together based on all the experience that I've had, a fairly typical situation where we have a project where they have 100 drill shafts. We've got a 100-foot deposit of intermediate geomechanical materials. I will take your pick, glacial till, Piedmont stuff, or any of those difficult to assess materials. The expected range for side shear in this material, 2.5 to 4 tons per square foot. Expected range for end bearing, 40 to 120 tons per square foot. And the expected range for end bearing and shale, because of the design I'd come up with, 100 to 500 tons per square foot. And the resistance factors that I was going to use for the code design, or what I've taken to call it the uncertain design. The uncertain design factors would be 0.4, and the certain design factor would be 0.9. So here's the picture of what we had, what we came up with, what I came up with. And you can see there's quite a difference in this, particularly these two foundation designs. But you notice that the working load requirement for both of them is 4,000 tons. The next step was a difficult one for me because I'm not in the construction end of things, so I called my good friend Lance Kitchens and asked him to prepare, a price estimate for these two designs. One a 72-inch shaft, 100 feet deep, sitting on shale, and another 36-inch diameter going down to 55 feet. And here's the spreadsheet that I came up with. You don't need to bother about all the calculations that are shown there, but you need to look at the bottom line here. And this is something that absolutely astounded me because I had no idea that there could be this much difference. But you can see that the cost of that project, foundation project, using the uncertain design was over $6.5 million. The cost of the certain design, 1.2 million. Now, when you look at that, you're thinking, my God, there's actually almost $5.5 million available for getting us from the uncertain design to the certain design. And how much can we do with that kind of funding? Well, I can tell you for sure that I could produce, I don't know how you go back with this. There you go. I could produce certainty for that certain design, certainty in the predictions, with probably about $1.5 million. It would involve a lot more geotechnical work, borings, and it would also involve testing the capacity of every one of those 100 shafts. So going back to this number, so that's let's say $1.5 million. I think it would be fair to say that the builder, the contractor, should probably get at least $1 million out of that to give him the wherewithal to really produce excellent shafts. So we've used up $2.5 million. That still leaves $3 million that would go to presumably to the owner. So if you look at that again, we've the actual cost of going from that $6.5 million uncertain design to a certain design is going to probably reduce that first number by $3 million. So the uncertain design total cost is going to be $6.5 million. The total cost for the certain design is going to be $3.5 million. I can't say that this is a typical number, but I can tell you, based on our experience, that it is not uncommon to have that kind of discrepancy. We've done all kinds of tests where our measured so-called factor of safety was 4 to 8 times the factor of safety that was used in the design. So these numbers are quite realistic. I put these concluding thoughts down here based on the written stuff that I'd put together, but really I would like to say in conclusion that I hope that this kind of information will encourage a lot of geotechnical designers to join what I call the 2H club. You know, producing 2 hypothetical designs like I have are armchair exercises. You don't have to go in the field, you don't have to do anything except sit there and think about the situation. And then, but the next important step though is when you've done those 2 hypothetical designs, get a cost estimate for the 2. And this immediately gives you the ammunition you need to convince people that we need to work towards certainty and get out of this acceptance of uncertainty in what we do. Right now, we're almost powerless when it comes to convincing people that the information we need for certainty is really valuable. I'm sure all of you have experienced what I call design by purchasing agent. And so we carry out this nice design. It gets submitted, it's in the contracts. The bids come in high, So the first thing that the purchasing agent wants to do is cut down the cost of all this testing. We've got a design, we've got the equipment, we're ready to go. Well, you know, you're engineers, you presumably know what you're doing. You've got a factor of safety of 2.5 on this whole thing. Let's cut back on the testing. So instead of four drill shaft tests, we'll cut it back to 2. I mean, hell, we could save $100,000 by doing that. And what's usually been our response? Well, we don't like it, but you know what can we do? You've got the money. And what we should be doing, and what we should have done all along, we say, okay, if you want to cut my design with whatever uncertainties I have in there is based on doing 4 load tests. If you're going to cut it back to 2, that's going to change. My factor of uncertainty is going to go up. And with a higher factor of uncertainty, this changes the design. And now you're going to have to go deeper, larger diameter. You're going to have to do something, but it's going to cost you. And we could probably fairly easily convince them that that extra cost is going to be a hell of a lot more than the $100,000 they're saving by cutting back on the test. But we've never been involved in that economic situation. And my last thing there is that $5,423,000 can buy a lot of information. And I know for sure that Jorj would love it. Thank you.